Hi, this is János, it's Real Audio, and I'm answering Nick's question. And Nick has been following my channel since the very early days for several years now, and he asked me a question about volume control, and I'm going to answer it. I'm going to read out his comment. I think this is the most authentic audio channel there is. Thank you, Nick. That's really high praise. Quite in-depth videos, a true audiophile and intelligent DIYer. More of my friends recognizing after years that tubes and high efficiency have more magic and switch, luckily. I'm going to build my own horn system in 2025 from birch ply. And later next year I'm going to ask someone to build a fully transformer coupled 300B, hopefully permanickel output transformers, and having a hard time to choose between resistor stepped attenuator or audio consulting silver rock transformer based volume control, TVC, that's a transformer based volume control, which some say the bass is lacking in comparison. So I'm going to share my experience with that, because some of you know, Nick knows that I'm using such devices for volume control in my system, and several of my friends do that, and both of them either resistive based volume control or transformer based, autoformer based. So lots of experiences, and my experience is that with tube gear, I would say that the TVC AVC approach wins by a landslide compared to a resistive approach. With the solid state amplification, I think the difference might not be as big between them, and I would say that with the solid state amp, the resistor based approach keeps the sonic character in line with what the system currently has, and it might react unfavorably to a transformer based approach. But I do not have much experience with that, so I cannot comment on it. So I think that's where this observation is coming from. Probably people trying out TVCs with solid state amplifiers. However, with tube amplifiers, what I noticed is that, especially here, I guess I'm not familiar with this brand TVC, but those TVCs I've used, and in general, especially if it's a silver TVC, it will take a long time for it to break in, and until then, with silver, you will notice that it's bass shy, or I would say it's not bass shy, but the top end will be just popping out a lot more. So it's not that the bass is quieter than with a copper based unit. It will be about the same volume, but the highs are just so massively more than you had with copper. Then the overall perception is as if it was bass shy, and as the silver breaks in, then the frequency bands normalize, and then you won't have that relative bass shyness. But given the extreme amount of wire in an AVC or TVC, and the low voltages involved, they take quite a while to break in. So before you really gauge how that TVC will sound in your system, it requires a really extensive breaking period. And after that period is done, I would say that there's absolutely no comparison between the two. The TVC is just head and shoulders above a resistive approach for several reasons. We have to look at also the volumes you are looking at where we are comparing the sound, because they really make quite a bit of difference based on the volume setting. So when you have the full volume setting, then a resistive approach basically acts like doesn't place any extra resistance in the signal path and provides a resistive return to ground. And you hear the sound of that resistor in the system. And if it's that resistor, especially for solid state systems, that's nice and stable thing, and it doesn't change, and when you change the volume, it's stable and it always does the same thing. So you have a overall same tonal character, same impedance matching behavior between the source and the amplifier. And when you have the transformer-based volume control, then basically the coils of the transformer, they will, and the stepping ratio between them will define the impedance reflected between the source and the amplifier. And depending on how your source and your amplifier are built and designed, they might react either favorably to changes in the impedance, or unfavorably. So favorably or unfavorably. And with that, it can be even that with a certain ratio, your system can favor it, and when you turn it down, and then it doesn't favor it, or vice versa. And that's why, especially those who are engineers and are into solid state engineering, their brain just explodes with the idea to have a TVC in the system, because all their precise calculations go out the window, because at full volume versus quiet volume, the impedance difference, how your source is seen by the amp, is just vastly different. So you cannot build a precise mathematical model around the transformer based volume control, because the gears are constantly changing. So from an engineering point of view, TVCs don't make any sense, while a resistive approach has the same impedance matching between source and amp constantly. So you would think that now resistive approach wins. However, the problem is with resistive approach that when we are at full volume, it doesn't put any resistance in series with your signal. But as we are turning the volume down, then it starts to put more and more resistance in series with your signal, and you are getting the colorations of your resistor, and and it's taking away from the signal, because what you are doing is you try to squeeze through the signal through a heavier and heavier resistor as you turn the volume down. So what you are doing is filtering out more and more of your source signal. So it's not only just getting quieter, but you are also losing detail level from it. And people with binary thinking will say, no, this doesn't mean anything. It's a resistor, and it's always just resistive, just the voltage changing. But it's not just what is changing. When you listen to these things, you get the experience, then you will notice it's not just getting quieter, you are losing detail level as well, and that becomes apparent when you compare it to a TVC, because with a TVC, as you step down on the volume, you are changing the ratio between your source and your load side. So basically the load is getting like fewer and fewer coils, which means that all that signal that's coming from the source is going out with a lower and lower impedance. So it means that it's getting higher and higher current drive. So basically, with a transformer, let's say we have a 2 volt input signal, and we are turning it down to a half a volt signal. When we have a resistor, then it cuts that 2 volts into half a volt, and 1.5 volts are burned up in the resistor and lost. When you do this with a transformer, then it does not lose any volts from the signal, but it exchanges the volt domain into a current domain. So it means that the same amount of electromagnetism is going through the transformer, and it gets coupled to your output side regardless you are at full volume or minimal volume. It's just that the transformer is shifting between providing more voltage when you are listening louder or more current when you are listening quieter. So basically what a transformer does is that it exchanges voltage to more current. So as you turn the volume lower and lower, you are increasing the current drive ability of your preamp, and essentially your ability to deliver signal to drive your load, your amplifier, becomes better and better as you step down in the output level voltage wise. And that's what you notice, that if your source, for example, is not currently impedance matched to your amp, and at full volume it does not have enough drive to drive your amplifier, as you are turning your volume lower and lower, it drives your amp better and better. So that's what people notice, that as you go quieter and quieter, that's when the TVC's advantages really kick in at the very quiet listening level, because there the torque that a TVC provides just becomes tremendous, and your amp is being controlled stronger and better. So unlike with the resistive approach, where as we are turning the volume down, we are burning up more and more of your signal, and we are compromising it more and more. And in the TVC, we are transmitting the same amount of electromagnetic signal that's generated in the transformer from the primary side to the secondary side. And yeah, so I would say that the TVC is always a win-win compared to a resistive approach. I've also noticed that there are big differences between TVCs, how they sound. They each have their own character, and if you want the ultimate, I would say an AVC is even better than a TVC. So an AVC is an autoformer that doesn't have separate coils. And when you have an AVC, it means that you have a single coil with multiple taps, and when you are using full output, then basically you have a direct input to your amp from your preamp with a choke in between. So you are basically adding a grid choke to your amplifier with an AVC at full volume. Actually, it's the same thing for the TVC as well. The secondary of the TVC acts as a grid choke, and I would say that the grid choke itself is a tremendous addition to any tube amplifier. And when you look into forums then, and people are searching for like the very last step to kick their amplifier to the stratosphere, the tube amplifier to the stratosphere, adding a grid choke instead of a grid resistor, that's the pretty much the last step to refine a system. And it is just tremendous. And then probably what you can do also, if you have a TVC or AVC, just you can play around with taking out the grid resistor and just use the TVC or AVC as basically as a grid choke for loading the grid. So basically what it does is that it has a return path to ground for any grid current with a very low impedance, but it has a very low impedance to DC but very high impedance to AC. And when we just have a regular resistor that has the same impedance to AC and DC, and when this is really important is when the system is playing louder, because that's when the tube starts to draw grid current. And when we have a high grid resistor there, like a 100k input resistor for the tube, then that doesn't allow much grid current to be drawn. It limits tremendously. When we put a TVC and it has maybe like a 3 kilo ohm DC resistance, then that 3 kilo ohm resistance allows like 30 times the grid current to be drawn by your input tube. And that's very critical, because when the tube cannot draw that grid current, that's when it starts to strain. And this will allow, the transformer allows your system to basically bypass your grid resistor and use the secondary of the TVC as a grid choke. And that's why TVCs for a tube amplifier are just a godsend, a really, really fantastic addition when played at loud volumes, because you have that massive grid choke there. And as you put your volume lower and lower, now two things happen. One of them is that you have better current drive for your input, but also your grid choke is getting smaller and smaller, which means as you have fewer and fewer coils, the inductance of that coil that your input tube sees as the grid choke becomes less and less. So it means that basically it acts, there's a less buffer between your signal and ground for the low frequencies. So it means that you are going to lose low frequency signal as you turn the volume down with a transformer based volume control or autoformer based volume control with tube input equipment that has tube at the input side of the amplifier. I would say personally this is not a very big issue, because as you put the volume down, you also expect the bass not to be as overwhelming, and the ear's ability to perceive deep bass, which is the one that's going to be compromised first, is much less at lower volumes. And that plays out in practicality, that even at lower volumes, to my ears, a TVC or AVC is still much superior to resistive load, because in a resistive volume control, because with a resistive volume control, when I am at the same volume, same lower volume, it has more bass at that volume, but at that volume it has heavier compromises in the mid-range and the high frequencies, and that's why with the resistive volume control, when you go down in the volume, you are losing detail level. It's not just getting quieter, you are losing detail level. yes, the high frequencies and the low frequencies, they drop at the exact same proportion to each other. With the TVC they don't. The deep bass drops more than the mids and the highs, but with the TVC the detail level doesn't drop, and with the resistors the detail level drops a lot. Plus you have the added benefit of a grid choke for the TVC or AVC. So my recommendation is, what is your priority? Because a resistive volume control still can be made to work well with a tube amplifier. It can, I have not tried it, but my suspicion is that it can be nearly as good sounding as a TVC at full volume when you also add a grid choke to your power amplifier. But that of course needs the extra space in the power amplifier for a grid choke, but you are designing your amplifier, so or have someone build it, you can ask him to build it with a grid choke, and in that case you can add the resistive approach to it, and at full volume it will sound just as good as a TVC. Now the change will be when you are turning the volume down. In that case, with this choice that you have the grid choke with your inside your amp plus the resistive volume, then you will have the better level of bass at, let's say, minus 10 dB, minus 15, minus 20 dB volumes, but you will lose noticeably more in other aspects of the sound. So I would say also this approach, putting the grid choke in the amp, is cheaper with a resistor attenuator, is a cheaper solution than the TVC or AVC, and I think there's nothing wrong with it. You can do it. My choice, what I am doing now, is that I have the AVC, and my reason for an AVC versus TVC is that with the AVC it has better ability to couple the signal and better ability to transmit, because especially when you listen to full volume, then there is no magnetism required to transmit from primary side to from input side to output side. You are getting the same signal out plus a grid choke in between. When you have a TVC, then you depend on the transformer to couple the primary side to the secondary side. So you are going to have transformer losses between input and output. And the advantage of the TVC comes when you have ground loop issues between your source and your amplifier, so that isolates the ground of your source and the ground of your amp. So especially if you have like issues with grounding, you know that, then you must go with a TVC, and that adds in any case like an added layer of more blackness to the sound of your amp. But having the AVC adds more dynamics, more power, more life to it. Plus, if you have like equal size transformer, equal size unit, if it's wound as an AVC, then it has double the number of coils compared to a TVC for the same purpose, which means it will have a quite higher inductance, which translates to better bass performance. And what you can also do is that if you have a TVC, you can rig it to become an AVC by basically connecting the primaries and the secondaries, so they are direct connected, and it becomes like a single big coil. But then you'll have to adjust the stepper part, because you will have to include the full volume, otherwise it will be just minus 6 dB because of the linking of the primaries and secondaries. And then you will notice how your TVC operates in an AVC mode, and then you will notice that it will be more punchier, more dynamic. You will get kind of like kicking it to level 11. So I think that's my long short answer to this question. And one more thing what I noticed more about it is that with my AVC, I have designed my AVC. I didn't build it myself. I had a master transformer winder make it for me, and actually he made 3 units. 2 of them are here in Hawaii. I mean 3 pairs. And when I compared it to other TVCs, it just a lot better. But I had one setting when I used it where the electricity of the house was pretty much compromised, and the ground was really dirty. There the TVC made a big improvement, because that decoupling between source and amp, in such cases it's critical. But when you have a very nice power line in your house, then going AVC will just kick it to the next level. So that's my long short answer, which got even longer. So thank you, Nick, for your awesome comment, and have fun with your approach, and enjoy building your horn. If you want to, you can ask, and just check in from time to time and let me know how you are progressing. And I'm really curious how it will turn out, what you choose, what drivers. And huge thumbs up for Baltic Birch. And by the way, surprise, I'm planning also a speaker build with Baltic Birch, and I hope I will build it within the next month. So I will report on that, on every aspect of that, and share all my findings. So thank you, Nick. Thank you, team. Bye bye.